So, good evening, everyone. I'm Mansa from APSSTC. Sorry for the delays due to some technical glitch. There was a problem. Hope you all know that we are APSSTC is conducting many webinars, technical and non-technical webinars to improve the skills of many students, unemployed youth, as well as the faculties all over the AP. So, as a part of that, we are conducting the series of webinars on latest trends. As a part of that, today we are conducting a webinar on reverse engineering, and today our speaker is Mr. Ganesh from Keeling. Ganesha from Keeling, he's highly effective trainee with more than 7.5 years of experience in project planning, job assignment and worksheet maintenance, surface and sheet metal design. He has extensive knowledge of wide variety of CAD applications used and assisted 25 plus projects. He stays constantly current with newly released and updates and incorporates them into training materials. He has handled hands-on technical workshops like two-stroke and four-stroke engine. Uh, it is a privilege to welcome you to the session, sir. Thank you. Thank you, sir. Sir, you may start the session.
Ganesh, unmute your audio.
Without wasting any time, okay, thank you, Manasa. Without wasting any time, let's start the session. So, sorry for the technical delay that what has happened. Okay. So, is the screen is visible?
Yes, sir, it is visible.
Okay, fine, fantastic. Okay, good evening to one and all. Let's start the session. As we know that we are in an engineering field, as the name, the title that what I have given here, Advanced Reverse Engineering. So it is a future of the product design and development. So as we know that there is an engineering. So engineering is an application of science and technology. So the reverse engineering itself says we're going to do the engineering in a reverse manner. So generally we're going to have different types of engineering and different types of disciplines. So here the reverse engineering not only just with the product development that what we have, but there is a scope for much more digital as well advancement that what we have seen nowadays, because in from the olden days till now we are having a continuous advancement in the technology. As we know that we are having different phases of manufacturing, product design and manufacturing happens in three phases. I can just put it in a brief manner. If I say that in a virtual mode, so we're going to have virtual prototyping and then rapid prototyping, and then we're going to have manufacturing. So all these three sectors will going to come under CAD CAM CAE. So that we're going to see further. So that's why I had given the advanced reverse engineering. Whatever the reverse engineering process has started along with the forward engineering. So with backup of technological advancement, we have got the digital platforms also. So we're going to see different things in this sessions. So this is an overview of the session. I will just introduce with engineering, what exactly the engineering is all about, what are the different types of engineerings are there. And with respect to the engineering, we have forward engineering and backward, that we normally call it as a reverse engineering. So, and then how exactly we have designed from the history. So history of design and its approach, how exactly the history was, how exactly we were designing the product and we were manufacturing, what are the different approach we were having to have a design and to get in terms of a realistic product. So we're going to see that, and then we're going to have different engineering design with different invention and innovation. So what is the difference between invention and innovation? That is very, very important for reverse engineering actually. And then we're going to see what exactly product life cycle plays a vital role in reverse engineering processes. And then what is the need and the purpose of reverse engineering nowadays? As the digital platform has been advanced, we are in a era of giving an order through Amazon, Flipkart, and also with different manufacturing product platforms. So we are in that. So we're gonna get a review in a second like that. So we're gonna have plenty of reviews over a product. So product lifecycle is a very, very vital role. Vital role. It plays a very vital role in reverse engineering process. So we had to know about it. So that I'm going to pitch on, and then I will going to say how exactly the reverse engineering works, what are the different processes are there, and how exactly it has got incorporated in the engineering field, and what are the different tools that we're going to use, and how many different kinds of applications are there in reverse engineering, and especially in mechanical engineering applications, how exactly it has been implemented. And we're going to see the different scanners and the different software platforms that we are using in reverse engineering processes. And also for the scanners are not only used for just scanning a model and replicate it in terms of CAD model, but the scanners are also used as an inspection or quality equipments nowadays. And what is the future of reverse engineering, and what is the scope for reverse engineering? So that and all we're going to see, and very importantly, the job opportunities for reverse engineering processes. And for those job opportunities, how exactly you have to be well equipped with the reverse engineering tools. What are the different things that you have to incorporate or implement yourself by upskilling and getting a job in these times of crisis, as we know. So that also come into picture, and you have to sustain with all the terms of conditions with respect to the environments and also with respect to the industrial loadings. So we'll move with the session. So as I said, we have an engineering, as I said. So engineering is an application of science and technology. So science is a mixture of physics, chemistry, and mathematics. So with the help of all these three main subjects, we have gotten plenty of products output, and also with the technology, with the platform of digital world. So in early days, we were following the forward engineering from the invention of wheel. So from the wood that what we have seen, by cutting that and chopping it. So and we have made that as a wheel, and we have made it with so many tools and made it as a movable device, and we have made transportation easier for us. So it is a traditional process of moving from higher level abstraction and logical designs to the physical implementation of the system. So this is what the forward engineering that we were having. Suppose in case, in some situations, there may be a physical part without having any BOM, that is bill of material or drawings, or you may have missing data of thermal and electrical properties. At that time, so we're going to have only physical part. We're not going to have any of other information as is mentioned here. So at that time, we made a reverse engineering. So we're going to have a physical product. We're going to have a reverse engineering process over it. So the reverse engineering process is nothing but a duplication of the existing component that what we have already, or sub-assembly the product. So we're not going to have any documentation. So we're going to have a scrap product. So using that scrap product by scanning it, and we can replicate it, and we can have a modification. We can have a design optimization for that particular product. So finally, we can have further development of concept, and then we can have a modification of the existing design that what exactly was earlier. So if we come to the history of design, so how exactly the design was made in early days. We used to have a draft, and we used to have a larger pads and everything. So we were having the tools and sketch. So all we were making with the help of all these kinds of drafts. I'm happy to share that I have started my engineering from 2006. So actually, we were the first batch to migrate from draft to as with digital world. That is, I started with the solid edge actually. So instead of having the draft, so from the migration, that is physical creation to the virtual creation, as I said, from draft work to modeling work, the CAD works. So that has been migrated. So from the history, so in history, so we were having all these draft table sketch, and by using this draft tool, we were creating the building structures, machine components. Each and everything was created by using these tools. So just to think of it, if we have all these papers and the tools, how it was very difficult to create the things with respect to the precisions and all those things. And also the documentation is not very much easier as we have nowadays, because we have cloud now. Cloud computing is there. So because of that, we have got a plenty of platform for virtual creation. Also, the documentation is easy now with respect to the PDM software along with the CAD modeling softwares. So to add on, so this is a picture of the layout that what they were making earlier days. You can see if you have visited any layouts, we're going to have physically. So it was a tedious job, as you say. You can see here also. So this was the draft. So now still the civil engineering has been used now. So the mechanical and other engineering platforms in some of the universities still they are using to have a conventional knowledge of the drafting and skills. It's very much needed actually. And now, so this is all about the history that what we had, the different types of designs, and the design was making with respect to the product development approach. We were having two approach actually. So one is conventional and then one is unconventional. As you see the screen, so the conventional method. So behind you are having a drawing image. So by with the help of 2D CAD drawings, so we were creating the CAD model. So starting with the geometric model using the CAD system, we were creating the wireframe or surfaces or solid structures, and then we were converting that into IGS, that is universal format or still binary format, and then imported in the format to CAE system, that is to generate a numerical solution. So as I said, CAD, CAM, CAE, computer aided design, computer aided manufacturing, and computer aided engineering. So all these three sectors are very, very important in any kinds of design. So here we were using CAD, so with the help of 2D, and then we were creating a 3D model and then converting that into a step format or IGS format, universal formats that we were using for any analysis purpose. And then for CAM systems, we were using it, and we were generating the NC code to have a manufacturing process. And next, as I said, we have unconventional or non-conventional process through product development approach used when the physical product is available but no CAD data is available. As you see the image, blur image behind the slide, that is SD and Java bike, and so this is an ambassador actually. So these are all the vintage bikes and cars that we have seen from our childhood days. But as I said, so non-conventional method, we have a physical model, but we do, suppose if you don't have a CAD data or any other data, so we can use these what a physical model and replicate it with the help of a scanned model. We can use the scanning operations and then we can have this entire model and then replicate it. So now we know that SD, so Java bike was there and they were manufacturing in Mysore actually. So now it has been extinct from so many years, but now the Java has been manufactured now with the help of world data and all those things that what they have taken and they have launched now. So therefore, now the capture of geometry molds the prototypes that what we have. So we're going to have the generation of the 3D CAD model with the help of the scan model. So then we're going to send it to the analysis purpose, or it may be used for NC generation. And this is what we called as a reverse engineering process actually. So next we move on to the further design processes. If we take the engineering design process, so yesterday you might have attended the session related to the new product development. So Shikhar has mentioned so many steps in new product development actually. So for to add on to it, so we are having the engineering design process that will come as first process. You can ask what exactly the problem is, what are the constraints. Suppose if I need a pen, so what is the purpose of using a pen? So the problem is with I need to write something. Suppose if I take an example of a pen itself, if I want to write anything on a sheet of paper, so I need a tool or a device to write it on it. So that is a problem. And what are the constraints are there? Whether I need to use it in pen or so ballpoint pens or different types of categories are there. So that will come under conceptual stages. So that will be an imagine. So that is brainstorming sessions as we're going to have a generation of ideas related to the different pens and different ways of approach of using a pen. So and then accordingly we're going to have a plan and we're going to draw a sketch or diagram and then we're going to create it and then we're going to improvise based on the physical feedback that what we're going to get from the customers. So now from here onwards we're going to have a reverse engineering process actually. So that I will give a clear clarity on the reverse engineering process when I come across with the product life cycle. So here, if as I was talking about the pen, so even if I take a mobile itself, so we're going to have different types of mobile nowadays. So with the reviews that what we're going to get it from the net, that is either from Flipkart or from Amazon or any platform that what we have now. So continuously we'll be getting continuous improvement in the product. So we'll be having a rating with respect to the performance as well as the what we can say that the life and the aesthetic wise, each and every aspects of that particular product will be reviewed by a customer, and that is visible for the entire product will be visible for the competitors also. So the reverse engineering process come into picture when you are having a competition with the industry. So each and every product will going to have a different manufacturers. So each manufacturers will going to look into the product and how exactly they have to compete with other competent so that they can have improvisation and also they have to sustain in the market. So otherwise, it is very difficult to sustain in a market and to have a continuous what increase in their profit and to sustain in a market and to enhance the existing product and also to continue their brand and to live with the customers. So so for any design engineering, so normally we're gonna hear a word called as invention and also innovation. So what exactly the innovation and is all about and the invention. So the major difference we had to know first, that is invention and innovation. So invention is nothing but creating a new thing. So as we know that car has been invented, aeroplane has been invented, bike has been invented, locomotive has been invented, and bike has been invented, and so many products are there. As I said, mobile, laptop, computer, so many systems. So as I said, laptop and computer system. So laptop is an advancement or innovation of computer itself. So likewise, we're going to see in detail. So what exactly these inventions are and what exactly the innovations are. How exactly the reverse engineering is correlated and very much needed for this invention and innovations. So in innovation, I will take up a few examples one by one, and we're going to have a glimpse on each and every product so that we can understand in a better way how exactly the reverse engineering has been adopted to those particular product, and how the innovation is different from invention. So if I take an example of cars, so as you see the screen, as the car has been invented, we were not knowing that it is a microcar, sedan car, CU or SUV or so many. So as you see the screen, now we are having a plenty of designs. So this is what we call as innovation. Car is an invention, and these different types or class of cars is an innovation. So this is how exactly the reverse engineering works. When you invent something, we're going to work on that particular invention, and we're going to modify some design or styles or aesthetic aspects or any performance aspects. So based on that, we're going to have a complete new product. So with some innovations. So for that particular product, again, we're going to have an invention or higher properties aspects. So next, if I take an example of bike also, we're going to have a different class of bikes again. So as I mentioned in the previous slide, so we are having a different types of class of cars, and also if you have a slight modification and also different application, as you do the innovation, always with the help of invention, we're going to have some product, and then with respect to the end user or customers, again, we're going to have a modification with respect to the end use and users. So based on that, we can have these types of different modification. If you have a truck, we're going to have a transportation. So basically, the transportation mode has a wide variety of applications. So truck has been used for transportation of goods and services. So likewise, so all these different types of class of cars are made for different purposes and also their different customers usage. And in the similar manner, if we take an example of bike, again here also in bike also you can see the screen. So we have different types of bikes again. So bike is an invention actually, and different types of bikes is an innovation. So this innovation comes through reverse engineering process. As the name itself says, reverse engineering. We're going to do the engineering in a reverse way. What exactly they have already been invented. So that is, you may have chassis. You can observe each and every picture. We're going to have different modification. You can see here, we're going to have a chassis, and here you can just observe the different form of chassis. Each and every bike has its own design in chassis modification, and also with respect to the diameter of wheel, that depends again. And main design modification that happens in a bike is a modification in a chassis, and also with respect to the fork and also tank, everything. Each and every product will going to have sub assemblies. We normally have. So if you just take this example itself, so we'll just go in detail for with respect to this example itself. We have a wheel, we have a chassis, we have a fork, we have a water tank, and then we have seats, and then a rear bumper, and we're going to have a supports all these things. So each and individual product has become a sub assembly. The whole assembly is a combination of sub assemblies. So each and individual product will be taken into account based on the chassis, the existing invention that what we have. Based on the chassis available, we're going to have a modification of that particular chassis with respect to the different load conditions. So that we normally call it as reverse engineering. Suppose you just take an example of this crossroad itself. It is an off-road and on-road bikes. So if I take this, it is the end use it should work on off-road as well as on-road. So then we come into picture while moving on off-road, we definitely have to look on the tires. So because it has to have a grip while moving. So these are all the aspects while we will going to look into the what modification of design that we normally call it as reverse engineering. That means what exactly the product is, what are all the components are there, what exactly it is meant for, what are all the different processes needed for that end application. Each and every aspects we're going to see in detail step by step. So we're going to have the new invention. So again, here each and every bike has its own end use. Nowadays, it has been completely migrated, and as we know about the eco-friendly, so we are having an advancement of these things from IC engine to the electric bikes and electric cars, as we already have. So now it is a boom for electric vehicles. So that is again a new innovation. It is not an invention, but it is an innovation with respect to the invention. Next, again, I will take one more example with respect to the bicycle. So in terms, we also call this as a bike. And here, again, if you see the screen, we are having a similarities in each and every product, but there is a change in each and every product. So bicycle is an invention again. Each and every diagram that what you are seeing is an innovation. That means aesthetically and application wise and the end user. So based on that, we're gonna have boy variant, girl variant like that way, and also so based on each and every application, you can see by having a visualization of this different cycle itself, we can extract something. So what exactly it is meant for, what purpose? So for again for trekking or for off-road run, or it may be for any competitions, or it may be any for what again it can maybe it may be for a trip, or it may be for any usage. So depending on again the end usage and the that what we look for, on that we're going to have in detail. Also we're going to take the chassis, and then we're going to have wheels. Each and every product will be taken into account. We're going to have a detailed study about it, and then we're going to concentrate on the end application. Based on that, we're going to have a design modification, and then further we're going to launch a new product. So that is what the reverse engineering is all about. Even if you take an example of cell phone, as we know that, so almost the phones that what you are seeing on the screen all are from our olden days. So no touch screens are available on a screen actually. So these are all completely old phones. How exactly it has been emerged since from last 10 years. So it's too much fast advancement, you can say that. So even the tab, the touch screens, everything. So that completely because of the advancement of technology, we have everything in a one touch. So through mobile itself, you can watch the video now and watch the webinars, and you can have an access to the internet. Everything, each and every aspects of our life has been converted, and it has been engineered through reverse way. And now what we are seeing as a gadgets. So as I was talking about the product life cycle, as I said, to sustain in a market, because as we know the pandemic situation now, so you can just think of each and every manufacturing sector. As we know that automotive and ESP, aerospace or airplane, we can say that. So now got a very hit on a market. So to sustain in a market, what exactly the changes has to be made, so and what exactly the customer need is, and based on all those things, and normally as I said, the new product development, how exactly they have to do, and what exactly they have to cope up with the existing product. That's what reverse engineering is all about. So what the product the company is launching, what exactly they have launched, and how exactly. So if I see this graph, product life cycle, as this says, when you launch a product, that is what we called as introductory stage. So the new product development, as you have seen the session yesterday, so you can just recall that session: idea, validate, plan, develop. Everything will going to happen in a pre-stage. After conceptual design and conceptual approval, after conceptual selection, all these things are of of this stage will going to happen, and then after completion of everything we're going to have an approval of conception, and then we're going to have engineering analysis, and then we're going to have manufacturing of it, and then we're going to launch into the market. That is called as introductory stage. As you can see the graph, as the graph indicates that introductory stage, it will be keep on increasing in the initial stages. As you have a launch of new product, we're going to have as I said, just to take an example of Java itself. So it has been revised and they have launched it again, but they couldn't able to make it up to the level of Java that what exactly was earlier with respect to the sound and the performance. But still, they have managed to bring it to the exact replica that what Java 350 and 500 was having earlier. But when it comes to the market, how exactly it will going to have a maturity and then decline stage. So initially we're going to have a growth because as you are bringing a new product to the what market, and then you have to cope up with the customers, and you have to understand customer what exactly they are giving normally. So as I said, as a digital platform has been advanced, we're going to have a continuous review in YouTube itself. Each and every product reviews are taken for R&D, for doing any reverse engineering. With respect to the reviews that what we're going to get it through YouTube and online shopping markets. So each and every product or company, everything will be reviewed in online basis and social networking. So all these we call into as service. So taking all that into account, we're going to have maturity stage. Suppose if you don't do any reverse engineering on the particular product based on the service that what we have made through online platforms, then definitely your product will be get declined. You can't able to sustain in a market. So to sustain in a market, continuous reverse engineering process has to happen. So otherwise, it's very difficult to sustain in a market. So that's why you can just have a just glance of the cell phone itself. Samsung has made an impact on cell phones actually. If you see the market previous for around 5 years before, so the touch screen and everything has got a boom through Samsung. Then and you know about Nokia. So because of not upgradations or not updating with respect to the what the market and the customer needs, if you are not having a cope up with or continuous updation with your skills and the technological advancement, then you can't able to compete with the existing customers. So now we were having different types of brands, MI, Realme, so many brands are there. So yeah, they are again competing with it. Next, so product lifecycle is very, very important. As I said, while having any product, existing product in a market, if you want to have a continuous sustainability in a market, you must see the product lifecycle, how exactly it is happening, and you have to continuously reverse engineer on that particular product what the upgradation that you have to make so that you can sustain in a market. That is very, very important. So that is how the reverse engineering process is required nowadays. So by having all this what information, so the need for reverse engineering is just we'll see one by one. Suppose if you original manufacturer of a product no longer produces a product, as is mentioned earlier, SD Java bike was there in Mysore, but now they are not producing it. But just recall it, so many years it was not manufactured in India, but now so it has been manufactured and they have brought up. Still, it has to cope up with the market. Next, second point, there is an inadequate documentation of the original design. As I said, even if I take an example of Ambassador or old vintage cars, we may not be having documentation, that is 2D drawings, we may not be having it. So at that time, we must have the physical prototype or physical model. Even if it is scrap, you can take that into stage and where you can have a benchmarking. So that I will going to say again. So the original manufacturer no longer exists, but external needs the product because even so many the customers who are fond of bikes, they wanted Java, so that has to be rebuilt and they has to bring it down. So based on the customer needs, so they have got it. The original design documentation has been lost as never existed. So as I said, if you have lost the document, then also you have a physical prototype or a scrap model. You can extract it from the software sophisticated scanners, and then we can get it back. Some bad features of a product need to be designed out for the betterment of the final product. So as I said, if some features are not up to the mark or making some trouble with respect to the existing product and which was reviewed by a customer, if I take an example of a bike itself, normally we'll go to have a visit to the service for bike regularly. So in each and every services, they will going to have a review on a particular bike variant, or even if you take a nano itself, or even nano also. So they will going to have a continuous review on that particular product, what they have faced, what exactly the customer is giving an information related to the product performances, what exactly they are having difficulties in handling. So each and every aspect has been taken into account while giving the service to the station. So all this comes into a survey mode, and then it will be reviewed and then reverse engineered and then upgraded and then launched again. And then to strengthen the good features of a product based on the long-term usage again, and also at last to analyze the good and bad features of a competitor product. As I said, mobile, why I have taken a mobile, because it is continuously improving and upgradation that is happening, and day by day. So within a week or in a month, we are having a launch of new uh, manufacturers, mobile manufacturers likewise. So as I was talking about the benchmarking, that is very much needed in an industry. So to gain a competitive benchmarking methods to understand competitors' product and to develop a better product. If I take an example of mining industry, automotive industry, aerospace industry, if you want to compete with those bulk transportation modes, so then you have to compete with competitors. So that suppose if I take an example of automotive industry, if you want to manufacture any product there, most important thing that comes into picture to reduce the weight of that particular product. So to reduce the weight, and you have to continuously maintain the functionality of that particular product, and you should not make what major designs in the existing product. If you make it, then obviously one and other. That means if you have a casting product, or if you have a machine product, or if you have a sheet metal product, each and every aspects will go to come into picture, and the type of assembly and fits of exactly are has been made. So if you are having a competitive product, if I take example of engine itself, Volvo engine and other companies engine, any other companies, if you are taking a benchmarking means, we're going to have that particular product, and then we're going to have dismantling of it, and then we're going to study that particular product, and then we're going to have a modification with respect to the existing product of ours. Then we're going to have design modification, and then we're going to launch it. So this is where the reverse engineering happens in conventional method. But nowadays, it has a little got advancement in that engineering processes, because we have the technology that what we call as scanners and the software tools. So with the help of those tools, we can easily extract the data, and then we can modify the data. So that I will say further in detail. So as I said, so the original supplier is unable or unwilling to provide additional parts. So then also come into picture. Suppose if you want to update the material that what has been absolute already. So as I was talking about the bike design now, it has been advancement from that normal steel to carbon fiber. So just think of it. So the bicycle were manufacturing with the help of the steel rods, aluminum, everything. Now it has got an advancement to the carbon fibers level. So likewise, we're going to have a continuous reverse engineering on each and every aspects of any product. Either it may be a material, or it may be a performance effect, or it may be aesthetic effect. We're going to have a continuous advancement. As I had given an example of car, bike, and then bicycle. So all these images that what you have seen has got an advancement with respect to the previous one. Either it may be in the form of aesthetic, that means look or style wise, or it may be in the form of performance wise, or it may be in the form of design aspects. So, or it may be a reduction of weight. So, and also reduction of cost at the end. So, and also we're going to see before doing any reverse engineering, we're going to see what type of customer it is. So, based on that, we're going to have a continuous reverse engineering process, and then we're going to have a continuous design modification, and again we're going to relaunch it. So, as I said, the need. So, if you have a need, then we'll definitely we're going to have a purpose for reverse engineering. So legacy parts replacement, so we're going to have a maintenance of that. And we suppose if you have a parts services and repair, and then if you want to do any failure analysis, as I said, each and every product. So all this, the purpose of engineering will come into picture when you have a product life cycle properly. So the purpose is mainly stick to that product life cycle. Each and every stages we're going to continuously observe that particular stages, 4 stages, and then we're going to have all these what purposes. So next we'll move on to the actual reverse engineering process. How exactly the reverse engineering process is happening nowadays, and what is the advancement of technology that we have got. And as you see the screen, so this is the modern reverse engineering process. It also involves the conventional method of creation as well as the recent development of scan to 3D model. So if you observe the first stage, it is a capture of three-dimensional data of a physical object. Earlier days we used to have these 2D data. So we're going to have a drafts, and then we're going to create that 2D data into 3D data. You can observe here, either we can have, that means this slide has got a blending of both. We have a 2D to 3D, or you can have a scanned 3D to again the parametric 3D. So scan data, we're going to have conceptual drawings or conceptual 3D models. So all these data will be there, and with the help of again CAD tool, we're going to convert the 2D into 3D, and then we're going to have CAD creation or design modification that will going to happen through different softwares. So then we're going to have the production, and then we can have an inspection. So even the scanners are used for doing the inspection of each and every product. So the process, as you are seeing here, so 2D to 3D conversion. So we're going to have 2D data, and then we're going to convert that with the help of different angular projections methods. So how exactly the reverse engineering workflow happens, as I mentioned in the previous slide. So this is how exactly the reverse engineering process happens. As I was talking from the beginning, so the physical part, we're going to have a physical part. Either it may be a scrapped part or it may be an existing part. We're going to have this physical part. After having this physical part, we're going to have a scanning process. The scanning process, what exactly makes is a generation of the scan data. Either it may be in the form of a point cloud data, or it may be in the form of mesh data. Either of two forms we're going to get it. Normally we're going to call a .pts model or .mesh model. So we're going to have .stl format model. So either of two types of model we're going to have, or either it may be in obj format also. So normally we're going to have a point cloud data, or it may be a mesh data. So all those scan data will be available. So with the help of scan data, we're going to create a mesh. Suppose if you have, just as an example of, if you have scanned it, you're going to have a generation of each and every coordinate points with respect to the structure. So then by using those points, we're going to have a generation of mesh that will be a triangular element. So by creating the mesh, then we're going to have region groups. Just take an example of this hole itself. So here you have a different types of holes. Each and every holes will going to have a different colors here. So this is grouping or making a regions of different groups of different segments. So each and every groups or regions are being created with the help of automation tool that has been incorporated in the plugin itself. So we have reverse engineering tools. I will going to mention it in further slides. So here, with the help of these regions, we can create a 3D model as similar to the scanned model with the help of region or groups. So by having a slicing method by creation of different planes with respect to the different profiles, that we're going to see it in for the slide, and also I will going to give a small video so that you can have a better understanding how exactly the process will happen. So after creating that, so we're going to have a 3D model and then we can have a final assembly. So even assembly, so as you have here, so we have three components, so it has got unassembled at the end. So as we are discussing about all these reverse engineering process, you may have reverse engineering is not only stick to a mechanical engineering application; it is also being used in each and every different fields of engineering. That is, it may be a computer science or it may be electronics, electricals. So each and every industry is having their own applications. In mechanical engineering, suppose if you take a military or aerospace, chemical industry or automotive industry, medical, life science, so each and every product has been scanned and modified based on the parameter that what I mentioned already. Either it may be a design aesthetic aspect or it may be a performance aspect. So or it may be of any other kind which was reviewed by a customer. So then what are the different benefits that we're going to get it through reverse engineering? As I was talking about each and every phases of product life cycle, we'll morely get into exploring existing design and news. That means we're going to have flexibility in design modification. So we can explore the new set of thoughts or ideas and we can incorporate it and we can have further innovations. As I said, if I take an example of all the transportation product, so either it may be a bicycle or it may be a bike or it may be a four-wheeler or a car. All these are having an advancement nowadays. So nowadays we are talking about electrical vehicles. So from the IC engine to the electrical vehicles advancement. So that is an exploration again. So that is an innovation again. So reconstructing a product that is outdated. So as I said, whatever the product that we were having earlier, so outdated product. I will just take an example of SD and Europuch. All these were having two strokes. So now it has got an advancement. So the two stroke has got an extent actually. So with respect to two wheelers, I'm talking. So next, discovering any product vulnerability. So that means if you have any modification, is there any scope for further modification in the existing product? So all this will be having a benefit of doing reverse engineering on any particular product, creating a reliable CAD model for future references. As I said, nowadays we are having a digital world that is a cloud, so we can have better usage of these clouds and we can store the data properly. So that instead of having printouts and keep it in somewhere and losing it, so we can have virtual data along with the what that printed data. So we can have transportation also. Suppose if I have a particular firm, if I am working for Airbus, I can work from here and I can communicate to a Germany through a PDM software with respect to the CAD software. So likewise, the cloud database is available. Each and every platform is available. So all these virtual platforms are creating advancement with respect to the technology and also making the reverse engineering process very easier. So as I was talking about the reverse engineering process, so the main thing in reverse engineering process is what by using scanners we can have the complete scanning of a model. So we'll just watch a video and then we'll going to come back to the slides. so that we will going to have a better understanding about the scanning and the reverse engineering process. Okay, fine. So we get back to the session. Is it audible, Sunil? Sunil or Manasa? Is it audible?
Yes, sir.
Fine. So as you watch the video, so we have got different types of scanners in each and every product that what you are seeing. So that is we have two different kinds of scanners. That is one is contact type and another one is non-contact type. So all these you have seen through video, so that you have got a better understanding as by just seeing through images. So in those videos, you might have observed without having any probe sensors. So the video that what I have just shown on both the videos, we were not having these probe sensors. So those two videos are related to non-contact type. So I will show one more video related to the contact type. So this is related to the contact type scanners where you're going to have these different types of probe sensors. Either it may be optical or it may be a laser related or photogrammetry or it may be a CMM. So that exactly, so CMM is very widely used in industry for inspection as I was talking about. Reverse engineering is the not only just a tool along with that inspection. As you have watched the video, it was showing different types of application by using a scanner. Not only for doing reverse engineering scan model, it was using for inspection also. It was using for many creation of a miniature. So all each and every aspects by creating the mesh or it may be a point cloud data. Lively, we can extract each and every feature of a particular product with the help of these scanners. So I will show one video related to the probe sensor where exactly the critical shapes can be extracted with the help of probe sensors. So for any complex models like car or aeroplane, so likewise, so we can have hand scanners like this. So this is of non-contact type. So it may be different variants, and each and every product has their own manufacturers. So each and every product can be used. That means to say that non-contact type can be used for any complicated, or simply we can say that larger products where you can have extraction of data. As an example, you have watched the video that is car. Either it may be car, it may be aeroplane. So for survey features, it would be better for non-contact type. Suppose if you are having an intricate shapes or engine type, there it will be there we're going to have a major usage of the probe sensors. So I will show one more video so that you can have a better understanding related to the what probe sensors. So as you've seen that video, so you can have a complete overview of contact types. So that means we were having a probe like this. So you can use this probe so that you can have a better profile extraction or a scan of that particular data. So as you see the comparison between the contact type and non-contact type. So in non-contact, as the name itself says, it is a contact type. Another one is non-contact type. We're not going to have a probe contact. So we're not going to have a probe contact on that particular product. So suppose if you want to have a detailed extraction of that particular integrated shape, then it would be a preferred usage of contact scanners instead of having non-contact scanners. So next we can have the different platforms as I was mentioning in the beginning. So we're going to have different types of scanners and different software platforms to convert the scan data into CAD data. So as you can see, so from scan to CAD data, you are having different steps, and also the tools are being used, and the output will be like this. So if I go for with respect to the first column, so we're going to have take a measurement of reference plot. So that information will be used to analyze the construction in order to create a new design file. That means to say we're going to have different types of scanners. As I was showing the video, we are having contact and non-contact type. Under that, we're going to have a CMM, or it may be a portable CMM, so or it may be a laser 3D scanner. So different types of scanners are being used, and we're going to have different types of CAD softwares. As we know about different types of CAD tools, so either it may be SolidWorks, or it may be CATIA, or it may be UG, or it may be Creo. So each and every software has their own interface. So we're going to have different graphic user interface with respect to the different softwares. But for timing, I have taken example of Extract 3D, add-in for SolidWorks, and also Geomagic for SolidWorks and Point2CAD. So majorly, so these software Extract 3D and Geomagics are being used as a reverse engineering tool for SolidWorks. So these tools are having a live transfer option for different kinds of software. What just I mentioned. That is either it may be SolidWorks, or it may be CATIA, or it may be Creo. We are having a live transfer in the sense we're going to create the exact similar model that what we normally create in a 3D model. That will be created with respect to the by using the Geomagic DesignX software. By using DesignX software, we're going to create a model. Either it may be a parametric model, or it may be a non-parametric model. After creating each and every profile, then we're going to have light transfer that I will show you to you in the end. So, and I will explain how exactly the process happens, and how exactly the reverse engineering tool has been used and converted into CAD file. So this is how the steps that has been used and different software platforms that we are having for reverse engineering. And you may, so normally in each and every reverse engineering process, we normally have one question, that is, which option is right for me? Either the industry may ask that whether I got to use what contact type, or whether I need to use non-contact type. Again, it depends on the type of product that what you are making as a reverse engineering product, and how exactly that scanning method is used to extract the data clearly. So the end product that what you're going to make, that has to got an what innovation or modification. For that purpose, you need to have a better scan data to have a better or very good quality data. So the usage or the selection of scanner is also very very important. What is the best method of scanning technology or technique that you will going to use? Based on that, the end product will going to reflect, because quality matters again. So with respect to the normal scanning or benchmarking method that what we were using earlier days, just what manually measuring each and every product and replicating it into 2D and then creating it to 3D, it was very complex. Now it is not like that way. By exacting each and every coordinate points, we can have almost what in micron, in nano level, we can have an accuracy. So that much of accuracy levels that we can see in scanners. As you watch the video, they were mentioning 25 microns, 50 microns. So that is the what depth of accuracy that we're going to get it through the scanning process. So to make the best use of it, whether we need to use a non-contact type or contact type, that again it depends on the type of shape or shape of the product. As I said, if I take the example of engine itself, for each very critical portions has to be extracted from the probes, and a few we can't able to move that probe. So depth of scan, everything that matters into account. So again, as I said, if a part contains complex organic shapes, we need to capture measurements of entire part. For reverse engineering, non-contact 3D scanners would be your best. So likewise, so depending on the requirement, we're going to choose either contact type or non-contact type 3D scanners, so that we can have a better scan data, so that we can use that data and we can recreate it with the help of CAD tools that what we have. So then about 3D printing, again the 3D printing in between, because as I said, we are having the process that comes under again CAD CAM CAE. I was mentioning earlier 3D printing. So suppose if you have a reverse engineering component, nowadays even a small component of by day what gift products, so that what we can see in gift shops or any markets. So each and every product is a mold product. So now because of the advancement of 3D technologies, that is rapid prototyping, assembly, so all this comes under additive manufacturing. So additive manufacturing has got a very much advancement nowadays for what product development as well as for reverse engineering process. As we now have an example of 3D built houses in Dubai. So in Arab countries, they are making the 3D printed houses also. So due to that advancement, and we are having a number of 3D printing types. So as you can see here, we are having the stereolithography, selective laser printing, and fusion deposition modeling that actually being used very much in small scale industries, and even smaller entrepreneurs are using FDMs. So there are different types of 3D printing technologies. So with the help of those 3D printing technology, we can have all these kinds of products with very less amount of time, and also we're not going to have any wastage of materials and all those things. So now the 3D printing technology is having a focus on getting a product with the help of metals and alloys. It's very difficult job to get to those type of product. So the research is happening towards that. So if we take these examples into account, even the 3D printing technology has been used for creating the patterns for mold object forecastings. So likewise, there are plenty of usage by with the help of 3D printing technology. As I mentioned, so through that scan data, you can enter directly to the CAD CAM CAE. So this is also a reverse engineering product by having a modification itself, and you're going to have a prototype, or it may be a pattern for making a casting, or it may be a jig, or it may be a fixture for creating a product. Because in engineering, creating a product is how much for creating a product, how much the important or the thing that we're going to incorporate in terms of design. Equally, the most important design that we come across is tooling. That is, to create a tool to create that particular product is a tedious job actually. So creating the jigs and fixture, it would be very helpful for recreation and modification with the help of reverse engineering. So that is an added advantage for reverse engineering process. As I said, the future of reverse engineering, again, it comes under CAD CAM CAE. So as I mentioned in the beginning itself, we are having rapid prototyping. So initially with the virtual prototyping, and then rapid prototyping, and then manufacturing. So this is the sequence of operation that we are carrying in industry. So we're going to have a scanned model. As I said, we're going to have geometric reverse engineering. This is how the process happens. If you have a scanned model, so with the help of that scanned model, we can create a CAD model and then send it to what a CAM, so that the NC generation, the profile generation will going to happen with the help of programming. The machine will going to complete that particular product with respect to the features that what it has. And also, before doing all these things, after creation, as soon you complete the product in terms of CAD, then we go for CAE. So we're going to do the engineering analysis, whether it will work for the existing environment with respect to the load conditions or the performance characteristics. So with the help of different CAE tools, ANSYS, so major ANSYS workbench is being used, Naston pattern. So many software CAE tools are there. So, and then we have Mastercam, NC programming software. So, and each and every CNC machine Fanuc and different softwares are what by machine itself they will going to give. So different industries will going to have their interface itself. So with the help of that scan data, just imagine all these three platforms are under the observation and also under the control of this reverse engineering process. So the complete process will happen through this media. And normally each and every person will going to have a question. So everything is okay. That means the technology is advancing and the situation is like this. And what could be the job opportunities for reverse engineering field? That means to say reverse engineering is a part of R&D. So as the name itself says, research and development. So that will happen through reverse engineering only. So where exactly we're going to have a design stream or design field. So there, all these job profile or designation that what are extracted through different job sites and job descriptions in industry. So they will going to call all these designations, either it may be design engineer, R&D engineer, CAD, CAM, project research technician, application engineer. So these are all the normal designation that you will going to get it when you get into the design stream of jobs, or it may be a R&D job. So these are the different job opportunities you can expect by knowing all these reverse engineering process. But fundamental and basic things you must know about it. So, how to be upskilled for reverse engineering? This is what the normal question that a fresher may have, even the experienced professional may have. So, as a fresher, what are the things that you have to know before entering into the design stream or for reverse engineering field? First, you must understand the language of a drawing. So without knowing the basic or fundamentals of drawings, that means suppose if you are having a civil engineering background, or it may be a mechanical background, or it may be electrical background, all these three different kinds of fields have their own application of drawings. Civil drawings will going to have different kinds of rules. So we know the drawing language has angular projections. In civil, we're going to call the front view as elevation and top view as plan. But in comparison with the mechanical engineering drawing, we call the mechanical engineering drawing with respect to the three views: front, side views, or normally we call them as a profile views. Either it may be side or left side or right side view as a profile view, and then top view. So with respect to that, the language of drawing, how exactly you have to understand the language, that is very very important, because without knowing this language of graphic, drawing is a graphical representation of the things that what we have seen. So the product or videos that what you have seen, if you want to replicate it, you must understand how exactly you have to replicate it. So by using perspective views, and also you must know parametric and non-parametric model. What is parametric and non-parametric model? Parametric, as the name itself says, by using the metric system, we're going to create a parameter that can be varied. Parameter can be varied. So that means if you have a rectangle, you're going to have a length and breadth. If you have a circle, you're going to have a diameter or a radius. So likewise, if you have a length and breadth or a diameter, you must have a provision to change it. So by using the CAD software. So that is parametric. Suppose if you have not given a dimension for that particular model, it is non-parametric, just a circle, just a square, by naming, by namesake we can call. And with respect to the geometrical constraint also you must know. And as I said, with respect to the scanners and everything, point cloud data and polygon slicing. So these key factors you must have understanding, and you must be proficient in any a CAD tool. Either it may be SolidWorks, or it may be CATIA, or it may be UG, or it may be Creo. Any of the CAD software you must know at least two software, I say. If you know those two, graphic user interface GUI normally we call, so we're going to have the graphic and we are a users. Between us, we're going to have a communication through the interface that we call it as a GUI. And now from the drafting to the MBD, model based definition, that is from 2D drafting to 3D drafting, has been having a migration from few years. So in my futures, that also come into picture. And also you must know about reverse engineering tool, as I mentioned earlier. So there are plenty of reverse engineering tools, most widely used Extract3D and Geomagic Design X. So these are all the commercial software they are using in industries. And you have what FreeCAD and MeshLab as a free source softwares as well. And as per experience concerned, suppose if you are already working in industry, suppose if you want to learn reverse engineering, you obviously you must understand the situation and the industries that what they are facing. So you must be proficient and you must be upskilled continuously. Otherwise, you can't sustain in any job. So you will be get fired. So you must continuously have an upgradation with respect to the skill, so that you can participate in an industry and you can contribute to your firm, and you can have your job safe. So for them, so they must have idea about point cloud data, polygon slicing. That means, as I said, as I mentioned, the different variants of extraction of data in terms of .pts and STL. Likewise, you must be proficient in any CAD tool. That is more than sufficient actually. So with the help of that, you can have a reverse engineering tool as an add-on. So with respect to this, I will just show you a video so that you can have a better understanding that what I have explained since from the beginning till now. So I will just show you a video with respect to one example how exactly the reverse engineering process happens with respect to the scan model by using the software. So this is one of the mechanical component that what you are seeing. So this is the scan data that what we have. After scanning, so we're going to have different types of region as you see here with respect to the different colors. So first we're going to have scanning of this entire model. After scanning the entire model, we're going to have the region or grouping by using the software. Either it may be a DesignX or it may be any other tool that we can use. So for time being, I have taken example of DesignX. So here we have different regions. So each and every region has had different colors. So that means we are having different mesh data with respect to the triangular shapes. So normally we're going to have a tetra mesh, so triangular elements. So the different types of our intricate shapes or curved shapes, we're going to have small triangles. Likewise, we're going to have different scanned triangles. So based on the profile that what we have, so we're going to select those particular regions. So by choosing that particular regions, we can have a normal extrude operation. Suppose if you know about the CAD software, you can understand in a better way that what the video is telling you. So here, by having this that reference, that is but with the help of a region, so you can have just this is a non-parametric model, that is just an extraction of circle, and then we are extruding it and we are matching with the scanned model. So we are just creating that with respect to the dimension that what we have in CAD model. So likewise, so you can have each and every operation, either it may be a fillet or it may be an extrude. So extrude is just what creating this circle with respect to the length that what we have. So and with respect to the number of profile that what we have here, so we have six of same kind. So we are using a pattern with the help of tool, then we are creating it. So likewise, by seeing the model, that is scan model, we are having section. You can have a visuality here. So here we are having a section. With respect to that, we have extracted a sketch. With respect to that sketch, we're going to recreate the actual sketch. So with reference to this reference, we normally extract these sketches and we're going to recreate it. And also along with that, we're going to have a constraint that is geometrically and dimensionally. So with respect to that constraints, we can say that as a parametric model. You can have this angle or chamfer, you can have this length. So you can have a variation further. Suppose if you don't have any modification in the dimension, then we normally call that as a non-parametric model. As you can see that we're going to have a continuous interface with respect to the scan model as well as with respect to the physical model that what we create. And then we can have the deviations. So along with this itself, it can extract the deviation, how exactly it is deviating from it. You can observe here the upper surface is sliced by with the help of this plane. So by creating individual planes, we can extract these outlines. So few automation tools are also available in the software, but with the automation tools, only few features can be created easily. But for complicated shapes has to be created with manual skills only. So that's why I said you guys that you must have at least 2 modeling software knowledge, so that you will going to have hold on graphic user interface. So you can extract the knowledge of extrusion, cut out, hole, creation, sweep, swept like this. So each and every software they has their own namings, but the process remains the same. So here this is a revolved part. So here we need to create a sketch and then we have to revolve with respect to this axis. So all these constraints that what you are saying is a geometrical constraint, not a dimensional constraint. We are not having any dimensions here, but it has got constraint with the geometry. That means it has got coincide, tangency, everything. Now it is now it has been created with the help of axis and then revolve command. Similar to your normal CAD tool, the CAD plugins are also having the similar set of commands, so that you can easily recreate the scan model and get the CAD model. So So this is a normal way of creation. Even if you are experienced persons or if you are already been in industry, you may have knowledge on Boolean operation as well. That means intersecting of two profiles and getting the required shapes, everything. So in industry, that is very much needed actually. So here also, by having or slicing that particular section with respect to the planes that what you have here also for to create this section or not. So exactly by using this arrow and with respect to the plane, you can adjust where exactly the section is needed. You can extract that particular position and then extract that sketch to the required plane or reference with respect to the distance, and then you can recreate this by using sketch tools. You can create by using splines and normal lines or polylines, and then replicate it and then create it with respect to the distance to where exactly the scan data is available. So to work on this reverse engineering tools or plugin tools, so you must understand how to read a drawing. As I was talking about the language of drawing, so that you can have a perspective views. So just imagine that just a conversion of 2D to 3D is a little bit tedious job as compared to this, right? Because you're going to have only two-dimensional drawings, and to convert that into 3D, just you will going to have one more interface in between, that is your mind. You must imagine that particular 2D virtually in your mind as a 3D, so that front view look like this, top view look like this, isometric view look like this. So all this will be having an imagination in your mind. And few components we normally give isometric as well, but still few features, critical features can't be visualized with the help of 2D. So the 3D scan data is very helpful in that particular section, and it makes a very reduction in the recreation of already existing part. So that is very very important when you come across with the product life cycle, because you have to compete with the competitors product, and also you have to launch very much as they do earlier. So before launching, suppose if you are competing with any kind of product, as I take an example of mobile itself. So before launching that particular competitor's product, you must launch first. You must upgrade yourself first with respect to the what the product aesthetic or technical things, any manner, in any what specifications. If you want to upgrade and if you want to compete and if you want to grab the opportunity in the market and increase your profit, so you must be in a position to respond to the customer feedback and must be in a quick manner, so that you can have a better product system and you can maintain your brand. I hope by seeing this video you got the entire overview of the things that what I've said earlier, that is engineering or reverse engineering is all about. And okay, so reverse engineering is all about, and what exactly the usage that we can see in engineering field, how exactly it is coping up with design optimization, and how exactly the products are developed with the help of reverse engineering, and how it has been used in a product life cycle, that is benchmarking. So that is a wide and vital application that we can see in each and every product industry, or it may be automobile industry, or it may be aerospace industry, or it may be mining, plenty of industries. So each and every industry has a scope for reverse engineering, and it will be continuously with the advancement of the tools. So you must be upgraded with the skills so that you can grab the opportunity, as I mentioned here. So you must be upskilled always. So otherwise, the market will not be there for you to get a job as well. So I hope I have completed with all the content that what I mentioned in the thing. So if you have any queries, please give in a chat section or let anyone to ask a question orally. Sunil?
Thank you, sir. Dear participants, if you have any questions, please post it in the chat box or in the questions tab. Even in the YouTube, you can post your questions in the comment section. I have sent the feedback link in the chat box. Please fill it. So there is a question in.
Okay, Bhavan.
Sir, I am mechanical engineering student specialized in CAD, CAM and CAE. What else should I need to know to have much more knowledge?
So, to add on, so as I mentioned, you can just see a slide. So, here, as I was talking about, you must know about this too. So as you know about CAD CAM CAE, you might be knowing SolidWorks or CATIA or any one tool. Along with that CAM tool, if you know about any MasterCAM or CAE, if you know ANSYS. So these are all the three basic software that each and every academic institute is having. So along with that, a reverse engineering tool that what I mentioned, that is geometric design X and extract 3D. So you have to what add these tools to your kit so that you can have a better job opportunity for performing or get into any design field. So to start up with, you can go with the free CAD and what MISLab also. So that is a free source software. So that is a little bit handy. So you can go with those two softwares. Or if you want to go with the professionals, you can opt for DesignX that is widely used in reverse engineering process. So because DesignX is having a platform to create a 3D model for SolidWorks, CATIA, and Creo. So directly you can directly transfer the exact tree that what you're going to create in that particular reverse engineering tool. The same tree that you can copy the or can have it in the particular software that customer requires. So that would be an added advantage if you go with the tools that is Extract 3D, reverse water design X or FreeCAD.
Is there any kind of training or resources that you can suggest?
Yes, you have plenty of online platforms as well as in Bangalore or in Hyderabad or in Chennai. So you can have plenty of option to go with the training institutes, and also you have option for Udemy. So, but one more important thing I can suggest you as a freshers and for any engineers who has completed their engineering. By having an online platform, you can't understand each and every bit of the things that what do in industry. So you must be having a physical trainer so that you can have a better understanding and you're going to have a continuous monitoring on your work that what you're going to carry out. Because whatever the models or whatever the assignment that you come across with online platforms, so you may do it but it can't be enough to understand in a better way. So if you have any set of institutions nearby you or if you come to Bangalore or if you go to Chennai, so you're going to have plenty of option. So there are various institutes they are giving this reverse engineering tools as training as well. So, Yes, any other further questions related to the reverse engineering tool, or I hope I have covered on behalf of all the students and experienced persons by thinking in your position. Still, you will be having a lot of doubts with respect to the process that what I mentioned, and also with respect to the opportunity that you have. Suppose if you have further questions, I can share the email ID with Sunil or Mansa, so you can have further queries through mail.
So Mr. Shambhar is asking for the mic permission. If you want to speak, sir.
Yes, yes, please.
Hello, hello,
Mr.
hello,
Sambasivarao గారు మీ వాయిస్ కొంచెం లోగా ఉంది. Your voice is very low. Could you please speak a bit loud?
hello.
Yes, please.
Yes, yes,
Uh,
it is.
Sir, for electrical engineering graduates,
Yes.
how can we cope up with reverse engineering, like software, something similar to that?
So for electrical guys, you'll be having a circuit diagram, right? So for PCB creations and all, normally we're going to have circuit diagrams. Even in the similar
Yes.
manner as we do in mechanical engineering, we're going to have different kinds of models in terms of features as you saw the video. But as the electrical concern, you will going to have circuit diagrams. Majorly the electronics and electrical will work on circuit diagrams, and also if you take an example of transformers, everything. So the wirings, everything. So there also we're going to have scope for electrical engineers. So the blending of, as I said, it is interdisciplinary actually. You can see that the mechatronics evolution. So in the similar manner, as you know about the circuit diagrams, you're going to have a scope for reverse engineering in the circuit diagram itself, because if you have a motherboard, as I said, the advancement of technology in terms of computers, there you will going to have a PCB. In that PCB, you're going to have circuit diagrams. That circuit diagram is not just a diagram actually. So if you want to change the shape or the reduction in the process, that means what different types of small products that you can come across with the circuits. So either it may be capacitor or it may be resistor. So how exactly you will be in a position, or how exactly you will going to do in a proficient manner to reduce the circuits with respect to the resistance and capacitance and different types of diodes that you will going to use, that also come into picture. That is also reverse engineering. You can see that a large CPU can be reduced in terms of small laptops and tabs and phones. Just imagine whatever the performance that we're going to see it on a computer, and the same kind of operation that can be carried out through laptops and tabs and now through phones, right? So that means to
Yes.
say that larger PCB board can be converted into smaller PCB board. So that is nothing but an reverse engineering process. That means you will going to do the reverse engineering with respect to the circuit diagram. For that particular circuit diagram, AutoCAD is more than sufficient, and also SolidWorks have been used in electrical industry, right? So for circuit
Yes.
diagram creation and all. So if you are proficient in those, and if you are capable of enhancing the existing design, that itself is a reverse engineering process with respect to the electrical and electronics background concern. So now what I have shown is related to the mechanical application concern. And if you come across with the civil engineering, so I will just add on to it. So for civil engineering, people, so nowadays, as you know about the quadcopters and all, we're going to have scanning of each and every area with respect to the scanning with the help of quadcopters itself. Just to take an example of Google Map itself, how we can get exact shape or distances with respect to the scanned images, because lively we're going to have source and destination. We can have a map and route map, but with the help of that we'll go from one place to another place with the help of live scanning with through water satellite itself. So each and every data has been scanned, right? So this is what the plenty of scopes are there. I think I have answered for your question, Pawan.
Yes,
Yes.
yes. Sir, one more
Yes, yes,
question I
please.
have. And presently, they are doing 3D engineering while constructing many houses and some products.
Yes,
Up to products, I am okay because they are small in size.
yes,
But what about houses? How they, because they will make a output frame,
yes.
so there is no 0.1% error. So after then, how can they proceed to construct with bricks and all?
So that and all, everything will come into what picture. So you can modify with respect to the what the scan data maybe of anything, but the in civil engineering, what exactly they will going to extract is the profile, how exactly the profile and the shape that what you have. The material concern that will going to be done with respect to the CAE tools. So the shape and what the profile that what you have that will be scanned first, right? So suppose if you just take an example of a bridge itself. So if you have a metro or anything, if I want to what scan that particular bridge with respect to that, so that dimension I will just scan it and I will just create it in what recreate it in CAD tool, and then I will just what check with the CAE tool whether it will work with respect to the desired load or not. Suppose if it's not working, then definitely I will not going to go for that particular design modification. So likewise, because they,
And
yes,
three doodler, there is one small thing, three doodler.
yes,
How where it will be used?
three doodle,
Like we can write on air itself, so it will be produced like a sticky paste. Like whatever we write in the air,
okay.
it will just shows like
I got it.
uh,
I got it. It is what 3D pen that what we're going to use. Visual
yes,
stress.
yes, yes,
So, but it is not going to get that much of accuracy with respect to the 3D doodle tool. So, a little bit it is what concern as.
it is just like some basic,
Yes, yes. For
right?
small components and all, you can have that means related to toys and all those things. So it will be helpful for that like things. So because anyhow we're going to get the smaller product like that. Instead of creating a sketch, you can have a 3D doodler, a small a pen like thing. So that you can show a prototype. So, but you
Yes,
cannot create a complete manufactured product. Or like, you can
yes,
have a
yes,
reference by using the 3D tool. So it would be very useful for having an interface. Suppose if you are a designer, if you want to convey the things to your co-partners or co-designers, then that would be an option actually, so that you can have a better interface. So whatever the things that you have in your mind, you can replicate that to 3D doodler. So by using that pen, so it will be very handy. Even so many tools are there like that.
yes.
Okay.
Thank you.
So,
So one more question is, how is CAD helpful in robotics in scope of ECA?
EC, just before I have conveyed the things, so robotics and all those things, as I said. So robotics is an integration of electronics as well as mechanical branch. So as I showed a video which was related to the mechanical component, and as well as mentioning about the electrical circuits and components. Again, we're going to what the major focus we can come across with reverse engineering for electrical fields. That means with respect to the circuit boards that what I have mentioned, and also the type of material that what we're going to use. So that can be what done through this modeling. That means different type of material that what we have as a PCB materials. So that will be of a different mode of approach in reverse engineering. So major focus you can have, that is, suppose if you have a DC motor or a AC motor, so the casing and the amount of what power that what we require, based on that he will going to have what he will going to give the input to the mechanical designer. He will going to do that component for you. and it is an interdisciplinary. So you have to cope up with a mechanical engineer, and mechanical guys you have to cope up with electrical engineer. So in that manner, it will happen.
One more question is, sir, I have a
Yeah.
proficiency in NX.
NX,
Will it
okay.
be sufficient for reverse engineering, or else should I learn the software suggested by you?
So you can have an add-on because so many people are using those software that what I mentioned, and also without having these softwares. That means before having Design X Extract 3D, earlier days we used to have reverse engineering through step model itself. That means by doing manual measurements and recreating it, and then converting into step model, and then recreating by using the professional what you have covered in that NX software. By using that also we can do reverse engineering. So there are plenty of software that can be used by using step model. But to create the step model, we require the sophisticated plugin software that what I mentioned. And even NX is coming with the reverse engineering tool, so it has a very good scope. So if you learn these two softwares or any what, if you are aware of these plugins, that will be an added advantage, and you're going to have more scope, and you're going to have more platform. That's it.
Thank you, sir. Many participants are requesting for the presentation, sir. So,
Okay, so that I will share. So any other further question? Is engineer role? Could you explain? Okay, so release engineer role. Okay. Okay, Anil, you are asking about the release engineer. As I mentioned, so while doing or while releasing the component, that means as a draftsman. So in engineering field, in design industry, we're going to have different types of designation that what I have mentioned in the job opportunities. So the release engineer will going to have different types of role. That means that may be of a different kind, a release engineer. So we're not going to have that as release engineers. We're going to have accreditations or approval engineers. So we're going to have application engineer or the release engineer. Normally, we're going to have the validation of the things that what they have created. Suppose, as I mentioned in the video, there we'll have scan data, and we're going to replicate into CAD data. After each and every application that what that we're going to use, that is either it may be CAM or CAE. So after that analysis and each and everything has happened, then final release will going to happen based on the type of material that what we're going to have. So the release engineer or launching engineer will going to definitely have all these knowledge must have, because he must know about the type of material that what they will going to use in that particular material that what they have scanned, and what is the end application, and how exactly it has been revised with respect to the base product that what it was earlier. So likewise, so all these come into picture. So before releasing or before launching a new innovation that what you have made with the existing product, so that comes into picture. So that is a major role for release engineer. Is nothing but a design engineer finally. So you're going to get approval from ASME standards associations. So all these come into picture along with IR property and all. I hope I have answered for your question.
so one more question in the questions tab regarding strength wise. Does 3D printed model has more strength or ordinary part has more strength?
So it depends again on the applications and the how complex model you have. Obviously, in reality or by common sense, you can say that 3D printing object will not going to have that much of strength that what you have in a normal way, but they are trying to achieve it. So the R&D is happening for that 3D printing objects. So 3D printing objects nowadays have been used as a prototype, and as I mentioned earlier, so 3D printed houses are also being made. But still, as compared to the regular mode of manufacturing or fabrication, you will not going to have that much of strength with respect to the 3D model types or 3D printed types. So, but they are advancing. They are looking into it. Sorry, can you please something? Okay. Why the design engineer are not getting decent pay in Indian market? So,
So Mr.
okay,
Krishna Chaitanya Krishna has requested for the mic, sir.
okay,
Chaitanya Krishna, you may speak.
Sir, actually, I
okay,
would like
and
to know one question from my
yes,
side.
yes,
For example, if we prefer 3D printing,
sorry,
if we prefer 3D printing when compared with an ordinary part,
yes,
but most of the now I have seen a previous video on YouTube which was recorded yesterday in an America there.
yes.
Uh, they actually by adopting 3D printing, nearly 4 out of 500 billions by making ordinary parts with the ordinary factory $500 million, they are going to cut nearly 60 to 70% of the cost of manufacturing parts. How can it be reliable? Manufactured part can be.
That's what I said. It depends entirely on application. Suppose if you are having a plastic product, it's of a different kind. Suppose if you are having engine parts, as you mentioned, so it entirely depends on the application. As I mentioned, if it is a what injection molding or any plastic parts for preparing, so you can have 3D printing with respect to the material combination that what you have researched. But if you are bringing that 3D printing technology to industry called automotive, suppose if you take an example of axles, so axles and engine parts, there you can't have a 3D printed product as compared to the original metal product or casted products. And comparison with respect to the performance, you can't have that much of strength and everything, and also you can't have withstanding capability of temperature. So all these factors will come into pictures. So as you mentioned, you are having what as we know that 3D printing is a future technology, because we're going to have reduction of cost, exactly that what you have said. You can have reduction of labor cost, because you're not going to have any what removal of material, chip generations, nothing will going to happen. You're going to have additive manufacturing. That's why it has been said as additive manufacturing. You're going to have a construction of continuous materials, that what you have opted with respect to the 3D printing process. So, but for different application, especially for automotive and aerospace applications, for turbo engines, or generally we can say that in turbines or engines. So for particular applications, it's still in R&D. So definitely in future, so all this machining process may extend, may be possible, because we can't say that it is impossible, because so many things has been evolved, and so many advancement of technology has happened that what we have not imagined at all. So definitely what you have said, that may be achieved in few years itself. Anil, okay. After the China-India dispute, India. So, Anil, I think you have asked that why we are design engineers are getting this, not getting decent pay. So, don't worry, we're gonna get decent pay in recent days, definitely. Because you have wide variety of scope now because of Skill India and Make in India concept. So many manufacturing companies are coming. Don't worry. So as this would self-initiated a lot of manufacturing companies, even companies from other countries willing to establish in India with this initiation should be made good career opportunities. And yes, that's what I said. So definitely we're going to have a very good opportunity in design sectors So don't worry, just keep upskilling your what knowledge that what you have, continuously open for knowledge, and continuously keep acquiring the knowledge so that you can have a better understanding with respect to the technology that what is happening, and also the benchmarking and related to the field of interest that what in your mind, that is very very important, because as being a fresher, as a it's of a different kind, because while working you will going to have different experience, and before working you will not going to have any imagination at all. So after blending these two, just what have a knowledge continuously on the current trends and the technologies that what you have, and what are the tools that they are having, and what type of different materials they are using, because each and every material upgradation is very very important. As I mentioned earlier in the beginning of the slide itself, the bike, that is a bicycle, has got an advancement from steel to the carbon fiber. So that way, so that is how we are having an advancement with respect to the technology tools. Each and every aspect is very very important. So keep upgrading yourself with respect to all these aspects, so you can have a better future definitely. Okay.
Thank you, sir. I hope all the questions are clear. So, participants, if you have any more questions, you can post it in the feedback form. There is an additional comments uh, tab over there, so you can write your questions. We'll forward it to the resource persons. Thank you.
Okay, so lastly, I will just convey. Okay, thank you for giving such a nice platform, and thank you, audience, for a valuable question that what you have asked. It means to me, and also very good questions actually that what you have asked. I hope I have answered to your all questions with respect to the knowledge that what I have acquired with my experience. And thank you, guys. Thank you, Sunil and Manasa, and thank you, audience, for such a nice session.
Thank you, sir. Thank you so much.